Okay, I believe I must be audible to everybody now, right? Okay, so let's start. In case you are not able to hear me, just try to rejoin. And we're going to talk about tRPC today. It's one of the most interesting libraries that nowadays is getting a lot of attraction, and it actually helps you to make pretty good type safe backends and like the overall application ecosystem. Right, it is able to give you like if you are someone who is very much fond of TypeScript and you want to write some interesting TypeScript backends, right? Then tRPC can actually help you. Okay. Now we're going to talk about what tRPC is, why exactly would you like to use it, and we'll try to see some hands-on around tRPC, that how we can technically use tRPC for multiple use cases. But first of all, I would like to show you the homepage of tRPC. Let me actually show you what does it says. Just a second, bring that in front of you. Okay. Okay, cool. So you can see move fast and break nothing. End-to-end type safe API is made easy. So if at any point of time you would like to make any kind of a type safe API, then tRPC gives you a end-to-end solution for that. Okay. Now, if you are already aware about RPCs, that is remote procedure calls, then it will not take you much time to actually understand what tRPC is. Okay. So, what is RPC? First of all, let's try to understand that. RPC stands for remote procedure calls. So, whenever you want to communicate from one system to another, whenever you want to communicate from one particular system to another system, then in that case, what do? You actually try to make API calls. Maybe it can be a REST API call or a GraphQL call, something like that. Okay. I hope my voice is coming clear, right? I hope my voice is coming clear. Okay. Just a second. I believe it should be good now. It should be good now. Right? Voice is clear, right? Okay. So as I mentioned that if let's say you want two systems to communicate, right? In case you want any two particular systems to actually communicate, let's say this is machine one and you want this machine one to communicate with some other machine which is remotely present somewhere else, right? Maybe on the internet. Okay. You want this to communicate. Maybe what you will do is you are going to make them communicate via some REST API calls or some GraphQL calls altogether, right? Cool. Now, what's the problem with REST APIs? What's the problem with REST APIs? One of the biggest problems with REST APIs is that they are not type safe. First of all, that's like the first and the foremost thing that should come to your mind, right? You're going to use JSON as the messaging format for REST APIs, and JSONs are not type safe, right? For example, there can be a case that in the JSON, a particular field is a numeric field, but the sender is sending it as a string because there is no type safety actually involved by default in JSONs, right? That's one problem with that. Okay. And now you can say that you can implement your, I would say, application level validation logic that can validate your incoming JSON. That's good, right? But that's kind of like a very fundamental problem with REST APIs altogether. You can say tRPC kind of like resolves that on the application level, but gives you a very simple and I would say straightforward interface to do that. So before I come to tRPC, I would like to first of all talk about RPC, that is remote procedure calls. Now, what is a remote procedure call? A remote procedure call is a type of a connection that you are going to set up between machine one and machine two, in which it's going to look like that you are going to make some simple function calls, as if machine two would have given you some kind of an SDK, and from machine one, you are just calling the functions of that SDK, right? It will not give you a feeling that you are making a call to any particular URL. It will not give you a feeling that you are kind of like giving a URL, a payload, a HTTP method type, so on and so forth. And it will just directly make the communication altogether. For example, if at any point of time you have used something like gRPC, right? So gRPC is also an RPC technology, right? Good thing about gRPC is that gRPC is available for multiple different ecosystems. Like you can use gRPC for Java, C++, JavaScript, and whatnot. Okay, Python, Go, everywhere you can use gRPC. And the use case of gRPC is very similar to this only, that it gives you kind of like a remote procedure call. That is, if one system has to communicate to another system, you are going to make kind of like a function call altogether, right? Now, good thing about gRPC is that gRPC doesn't use any kind of JSON. Instead, gRPC use something called as protocol buffers. These protocol buffers makes your gRPC calls type safe. right? Now, the thing is that gRPC it's kind of like a whole ecosystem, and it's technically maintained by Google and a lot of different I would say tech stacks you can integrate gRPC to. Now, talking about specifically tRPC, tRPC is kind of like an end-to-end solution specifically for TypeScript. Okay, if you are building your backends and frontends in TypeScript, right, then tRPC is a good end-to-end solution for you. Why? Because tRPC is going to give you again that remote procedure call feeling. tRPC is going to give you that remote procedure call feeling that you are going to make a function call as such, and internally it will handle all the networking for you. It will handle how to make the network call to a particular URL, what method to send, so on and so forth. Everything it will automatically handle for you, but it's specific for TypeScript. It's specific for TypeScript. And if it is specific for TypeScript, then it means then that it has type safety out of the box, right? And that's one of the most problematic thing that used to exist, right, in I would say normal REST APIs, that tRPC technically resolves. And to be very honest, this is kind of like a disadvantage with tRPC as well, that it's only available with TypeScript. If you want to use tRPC with any other tech stack, let's say maybe Python, it's not available. You can only make a tRPC application using TypeScript altogether. Whereas on the other hand, the other RPC solutions, like for example gRPC, you can use other ecosystems as well to integrate with gRPC. But gRPC is not the discussion for today. We are going to talk mostly things about tRPC altogether, right? Okay, in case you want to understand more things about protocol buffers of gRPC, so you can Google about protocol buffs or protobufs. Okay, you can say protocol buffers are kind of like a, you can see, message exchange format that gRPC uses. Protocol buffers are the message exchange format that gRPC uses. Okay, just like your REST APIs use what? JSONs, right? Protocol buffers are used by gRPC. Okay, so what you do is you make a protocol buffer file, and then you compile your protocol buffers in the corresponding language, and it automatically generates all the corresponding RPCs and all the messaging functions and everything for you automatically. For example, let's say in gRPC, you create a protocol buffer file, right? Every protocol buffer file has an extension .proto, and you create something like a message person with a string name, int ID, and string email. So the payload that you are expecting to send in an RPC call is a person payload. So what it will do, if you compile this protocol buffer for Java, then it is automatically going to give you all the Java builder classes. So you can see it will automatically give you a person builder. So you can say person.new builder, set ID on that, set name on that, set email on that, and then wherever you want to use this person, you can use that. Okay, and similarly you can define specific RPCs as well, and then automatically those RPC function calls will be available to you. And as I mentioned, RPCs are going to give you a feeling that you are making just simple function calls, right? Internally they will handle everything that is required for the connection to be set up. However they want to set up the TCP connection, let's say it's I would say reliable connection that they want to set up. So whatever is needed to maintain the TCP connection and send data on top of the TCP connection, everything RPCs internally handle for you. That's interesting. Is this point making sense to everybody? First of all, tell me that. Is this point making sense? Okay, good. Any questions so far? Any questions so far? We'll first of all try to set up tRPC. Vivek, we'll first of all try to set up tRPC. Okay. If everything is good to go, let's try to see a couple of concepts that tRPC actually gives you. Before you start setting up tRPC, you can see some simple code example videos you can actually see here. You will see a couple of words floating around here and there, like procedure, query, mutation, you can see query, and so on. So in case you have worked with GraphQL at some point of time, considering, let's say maybe, just maybe, if you have worked with GraphQL at some point of time, you must be already aware about something called as mutation and query and so on and so forth. These terminologies you might have already heard about in case you have worked with something like GraphQL. Or if let's say in React, you might have worked with React query, then also you might have already heard about something like query, mutation and everything. But don't worry, I'm going to go over all of these concepts one by one, that what is a query, what is a mutation, so on and so forth. Okay. So first of all, before we get started, you can see it's pretty easy to get started with tRPC. How? You can just install the corresponding tRPC server and client packages and get started with it. Okay. You don't have to worry a lot altogether. But before we get started with it, I would like to talk about a couple of concepts. Okay. So if you go to the concepts part, you can see what is RPC. It is just function. As I mentioned, RPCs are just functions. Okay. Right. Whenever you are going to make an RPC call, it will feel like you are making a function call. That's it. Internally, it will handle all the networking stuff for you. For example, if you are making a REST API call using fetch, this is how your syntax looks like. But if you are making a API call using RPC, this is how your syntax look like. And can you see, this looks more like a function call. Okay. And you can see, you don't need to think about the HTTP and REST implementation details. Everything will be automatically covered for you. You can see, if you inspect the network traffic of a tRPC app, you will see it is a fairly standard HTTP request and response, but you don't need to think about the implementation detail. You do not need to think about how the network call will be made, what is the HTTP method to be done, so on and so forth. You don't need to care about that. Okay, cool. Now you can see they have given a very good glossary of some important terminologies that you are going to very regularly read or come across when preparing a tRPC application. The first one is a procedure. Now, what is a procedure? You can say that procedure is going to be an API endpoint, which can be called by the client to send and receive data. Okay. So just like you are going to prepare an endpoint, let's say if you maintain a REST API. So in REST API, you maintain endpoints. Here, instead of saying endpoint, we call it as procedure. You can see API endpoint. Okay. We call it as procedure. And a procedure can be of three types. A query, a mutation, or a subscription. What is a query? Query is that kind of endpoint, or query is that kind of procedure using which you are going to fetch some data, just like you do it in GraphQL. And mutation is that kind of endpoint, or mutation is that kind of a procedure using which you do some side effects, like you create something, you delete something, or you update something. So whenever you have to create, update, or delete something, you write a mutation endpoint or a mutation procedure. Whenever you have to get some data, you write a query endpoint or a query procedure. Okay. And what is subscription? If at any point of time you want to make a persistent connection on top of which you can listen and send data persistently, then you make a subscription endpoint. You can make a subscription endpoint internally by using WebSockets. Okay. These are the four most important terms that you have to understand if you want to get started with tRPC. Okay. So what is a subscription? Endpoint. Like just like how you make an API endpoint with REST APIs, here you do not make an API endpoint. You call that as a procedure. Okay. You call that as a procedure. You can relate the term procedure with stored procedures in PLSQL or RDBMS, right? Because in RDBMS, what is a stored procedure? Stored procedure is just a function, right? So here they have taken kind of like a similar kind of a terminology, procedure, because RPCs are also all about function calls. So procedure is your technically function call. Okay. And a function call is going to be your endpoint. And it can be of three types: query, mutation, subscription. Query is those kind of endpoints which is going to fetch some data. Mutation is those kind of endpoint which is going to technically create some kind of a side effect. Okay. Maybe deletion, updation, or creation. Subscription is going to be for persistent connections altogether. That's okay, right? Now, there is a term called as router. Router is just a collection of procedures. A collection of endpoints is going to be a router. What is a context? Context, stuff that every procedure can access. So context is a common data that every procedure can access. For example, you want to have a DB connection object, right? You want to have a DB connection object inside multiple procedures. You can share that across procedure by putting it inside a context. Okay. Then you have a middleware, a function that can run code before a procedure, just like how you have middlewares in Express. And validation. Does the input contain the right stuff? So any kind of a validation, if you want to do, then you have to maintain validations altogether. To be very honest, this is the whole majority details or terminologies that you are going to get floated around whenever you are going to prepare a tRPC application. Is this point making sense to everybody? Say yes or no in the chat. Like try to relate it with API endpoints that you prepare with REST APIs. Okay. And try to prepare, like just think about, like try to map it. Okay. Do one thing. Just try to map it. Whatever you know about REST APIs, try to map it with those kind of REST APIs. Okay. Try to map it with those kind of REST APIs. Is this point making sense? No. tRPC doesn't have a direct concept of interceptors. Okay. You need to use middlewares for that. Okay. Cool. Coming back. So let's get started with it. Let's try to get started with all of this. Okay. So what I'm going to do is I'll come to my terminal. Now we know enough. Now we know enough. And I believe we can have a quick hands-on. Okay. So okay, I'm going to make a directory tRPC demo. Okay. Now, okay, one interesting thing. Because of the fact, now just think about it. As I mentioned, now you are not going to make an API call directly from machine 1 to machine 2, kind of like this. So in case of a client server interaction, how does a client server interaction looks like? How does a client server interaction technically looks like? There is one more problem. Like one problem I told you about tRPC is that it's specific to TypeScript. One more problem about tRPC is that any kind of a client or server interaction needs to happen inside a monorepo only. Monorepo or a monolithic repo. That means your client side code and the server side code needs to remain in the same repository, because all the types are shared across the client and the server. So that's kind of like make it problematic. Okay. That is kind of like problematic. Whereas if you see gRPC, in gRPC, you can make the same protocol. Like here also you can do that. Like if you want to have multiple repos, you can make the same types in different repos, but it's going to be little bit complicated. Whereas in gRPC, you can just replicate your protocol buffer from one service to another service, and you can separate it out. When I say monorepo, then I mean kind of like a monolithic repo only. Monorepo, like it's kind of like a implementation, or I would say explanation for kind of like a monolithic repo. Okay, in which multiple components of your project stay in the same repo. For example, I'm going to make a separate client project, I'm going to make a separate server project, but both of them are going to stay in a single repository. They're going to be separate projects, right? So it's kind of like slightly a bit different from your regular monolith. For example, if you have ever worked with Ruby on Rails, okay, so in Ruby on Rails, your client side code, server side code, both remains in the same project also. Here, your client side code is a separate project, server side code is a separate project, but both of them stays in the same repository. Both of them stays in the same repository altogether. That is something that I'm talking about. So both your backend and front-end code should be in the same repo. It can have separate projects, but it should be in the same repo so that you can export and import types altogether, right? This is like, I'll show you by making one of these. But this is something that you have to keep in mind, that whenever you are making a tRPC project, this is how the overall architecture is going to look like. You're going to have a certain set of types. You're going to have, let's say, a certain set of types defined. Okay. Then you are inside the same repo, you are going to have a front end. Inside the same repo, you are going to have the front end. Inside the same repo, you are going to have a backend. Okay. And then this is going to be the backend code base. This is going to be the front end code base. Okay. The front end code base, let's say you can write in React and TypeScript. Okay. And the backend code base, let's say you can make in Express and TypeScript. And then they are going to share these types. They are going to share these types. And all of this is going to be in a single repo, in a single project repo. This kind of an architecture is called as a monorepo. Okay. So let's try to set up one. So this tRPC demo, the I would say directory that I'm preparing is going to be kind of like my monorepo. Okay. Cool. So I'll go inside this tRPC demo. And the first thing that we can do is we can make a backend directory. CD backend. Okay. I'm inside tRPC demo backend. And similarly, along with backend, we can make a client as well. Okay. So we have two directories altogether. Backend and client. And this tRPC demo is our monorepo altogether. I'll go inside the backend one. Let's try to set up the backend first. The first thing that we should technically do is npm init -5 so that we can set up a npm project here. Okay, so we have npm init -5. Now, what all things do we need to install? What all things do we need to install? So we need to technically install a tRPC server. Okay, the first thing that we should do is we should install @trpc/server. @trpc/server. This is the first thing that is kind of like mandatory for you to install, right? Apart from this, there will be a few more things that we need to set up. We will install Express so that we can set up because the React frontend will need to actually interact with the backend, right? So this whole backend we are going to, let's say, prepare with Express. We need to install Zod. Why do you need Zod? We can use Zod for any kind of a validation. Okay. We'll need Prisma so that we can, like, Prisma is if you don't know about Prisma is an ORM that supports, like, that's kind of like supporting your TypeScript based type safe backends. Okay, so you can see Prisma is your ORM and it has a very good support for TypeScript. So if you want to use an ORM, you can even use Mongoose and everything, like, if you want to connect with MongoDB, but Prisma has got a really good support for I would say type safe backends, or I would say the types that you want to create. Okay, so we'll install Prisma and let's wait for it, and we can just get started. I believe I'm installing the right one. Yep. Let's see why it is stopped. npm install Prisma. Let's see. Okay, now it's installing. Okay, so we have Express, we have Zod, we have Prisma. Okay, let's wait for it. Okay, it's taking some time. Let's wait for it. Okay, and along with this, like, I can show you, like, I'm going to set it up with MySQL, so you can check Prisma setup with MySQL. So you need to use the MySQL2 driver. Okay, you will need to use the MySQL2 driver as well, right? And this is the kind of a file you need to create with Prisma. So let me show you. So you can see you have to create a schema.prisma file. And then you can define whatever schema you want to have, and it will automatically handle all the DB calls and everything for you. Okay, you can see Prisma is up, and I'll use, let's say, @prisma/client. There is one more package, Prisma client. I'll show you very quickly Prisma client as well. Prisma client npm. Okay, you can see what Prisma client does is it is going to generate your query builders. It is going to auto generate the query builders whenever you need to query your database, right? It will generate the builders for that. Okay, so you need Prisma client as well. Okay, let me know if you guys have any questions. And most of the things looks good to go. Right, let's open the code base, and you can see we have all of these things in place. Right, cool. Now the first thing that we should do is we can do npx prisma init. What npx prisma init does is it is going to create a Prisma file automatically for us. Okay, you can see it has created a Prisma folder, and inside that it has created a schema.prisma file for us. And this is where we can technically write anything that we want to set up in our database. Okay, make sense, everyone? It's kind of like all the models that you are going to write. Let's say if you do kind of like MVC architecture in models, you want to have controllers, you want to have services, the models part, that how the database should look like, all of that technically goes here. Make sense? Okay, cool. Now here what you can do is you can make the provider as MySQL, because I want to use MySQL. I have MySQL in my machine, and we can take the database URL. Like for now, I can just put the database URL like directly. So you can say MySQL : // the user of my database URL is root : for now, I'll just directly put the password also here. If like you can avoid it, or maybe let's do one thing. Let's keep it from the database, like keep it from the environment variable only. I don't want to expose my because it will be having a password, so I don't want to expose that. Okay, and that's it. When you say provider MySQL, it is going to generate everything that is relevant for MySQL altogether. Okay, cool. Now, what you can do is you can start writing your model. So let's say I want to make kind of like a URL shortener. Let's say I want to make a URL shortener. If I want to make a URL shortener, how the database should look like. Inside the database, I can keep the original URL of the URL shortener. I can keep the shortened URL of the URL shortener. Okay. So I'll say URL, model URL. Okay. And I can keep first of all ID, which is of type int. Okay. ID, which is of type int. Slug we do not need. We do not need a slug. Okay. We can keep a URL, the original URL. Let's call it as original URL. Original URL. Okay. This is going to be of type string. Let's keep a shortened URL. Short URL, which is also going to be of type string. And the shortened URL should be unique. Okay. So this is how you can define a Prisma file. This is how you can define a Prisma file. Right. Let me put all of this in one column. Okay, here we go. So this is how you define a model. You do not need to make separate model files if you are using Prisma. You do not need to make separate model files using Prisma. Okay. And that's it. This is the only thing that you need to do if you want to set up a model using Prisma. Any questions? Anyone having any questions? Okay. Now I need to set up my environment variable. So let's do one thing. I'll take this terminal window and I'll separately set up my environment variable so that I do not expose my password. Yeah. Although I don't use that password anywhere else, but I still would like to be a bit conscious. So what's the name of the variable? Database URL is equals to okay. I guess I have my database URL added as the environment variable here. Okay. Now, what do we need to do? Because we have the Prisma file here with us. We have the Prisma file here with us. Now, what we can do is we can call the Prisma migrate. So there is a command called as npx Prisma migrate. Okay, npx Prisma migrate. And using this npx Prisma migrate, what will happen is your database, whatever database you want to have, right, whatever is the model that you define for that database, everything is going to be automatically created for you. Okay. So we can say dev, and we can give the name, let's say minus in it. The moment we do this, let's quickly check. Oh, my bad. I guess I put the wrong DB URL. Just a second. Let me change my environment variable very quickly. Okay. Just a second. So I need to define it in a certain way. Just a minute. You can just set up your own MySQL server address. Okay. Okay, let's come back. Let's come back here. And here we go. Okay. So now you can see it says MySQL database tRPC URL shortener created at localhost 3306. Okay. And if I open my MySQL instance, okay. And if I say show databases, and if I show you, you can see there is a database tRPC URL shortener. If I say use tRPC URL shortener, and if I zoom it a bit, show tables, and you can see we have a URL table coming into the picture. If I say describe URL, you can see we have a ID property, original URL, shortened URL, created at and updated at. Pretty simple and straightforward to set up a schema altogether, right? Make sense, everyone? Salman, to be honest, I don't use the password anywhere else, but I just want to be 99, like I'm 99% sure. But although I just revealed it also, like I just uh, use my up arrow key and revealed it only, so doesn't matter much. But yeah, but I believe this much part is making sense, that we have a quick migration file, and you can see this is the migration file which is going to show us what migration it actually created, right? I believe everybody knows about migrations. It's kind of like version control for your databases. It's kind of like version control for your databases. Can I say that? Make sense? Any questions so far? No questions? Cool. Now, if you remember what were routers, routers were a collection of procedures, right? So how do you create the project here is, let's say if you have a source folder, inside the source folder, you can create a new folder, called it as routers. Okay, you can call it as routers. And I can create one router called as URL router.ts. I can make URL router.ts. So I can make a TypeScript file with URL router. Okay. The first thing that I can do is I can import Z from Zod. Okay. And what I can do is I can start writing my router. And if you remember, router is a collection of procedures. So you can say export const URL router is equals to now what you need to have is you need to have a context. If you remember what was a context, context was the data that every procedure has details about. Context was the data that every procedure has details about. So we need to make a context file as well. So what I can do is inside source, I can create a new file, context.ts. Okay, context.ts. And I can say import Prisma client from Prisma client, right? We just need Prisma client. And what we can do is we can say export const p is equals to, now every context object, if you want to at any point of time create a context object, if at any point of time you want to create a context object, let me show you how you create it. You can see from your tRPC server, you get a init tRPC function. Can you see? From your tRPC server package, you get a init tRPC function, right? And what you can do is you can call init tRPC.context, and on top of it, you can call the create function. What this is going to do is this is going to create a tRPC context object for you. This is going to create a tRPC context object for you. This is something that you have to keep in mind. Are you guys able to get this point? Are you using Docker for checking? No, I am not using Docker, Harsh Kumar. I'm not using Docker. Is this point making sense? That how can you make a context object? Everybody. Okay. So let's do one thing. Here we'll also import init tRPC from tRPC server. Okay. And we can say const tRPC is equals to init tRPC dot create. Okay, we can call the init tRPC dot create function. Are you guys able to get this point? Can I get job through Java? Yes, you can. Is this point making sense? What is this tRPC object technically doing? And we can say export const tRPC. We can do a named export here. Is this point making sense? Everybody. So what you need to do, you need to first of all create a tRPC context object. You need to make a tRPC context object first of all. Once you have a tRPC context object, you can import it. You can say import tRPC from context. And now you can set up your URL. Or I would say you can set up your router. How do you set up your router? You can say tRPC.router. So this tRPC context object that you are going to prepare is going to have a router function. this router function takes an object, and inside this object, every key is going to be a procedure, and in the value you are going to give the implementation of the procedure. For example, I can have a procedure get short URL. This can be the name of the procedure, and then I can give the implementation of the procedure. So how do we give the implementation of a procedure? From the tRPC context object, you call the tRPC dot procedure method. Are you guys able to get this point? We call the tRPC dot procedure method. The moment you call tRPC dot procedure, this get short URL is created as an RPC for you. Okay. Now, on this procedure object, you can define the input. You can define the input. That what will be the input for the procedure. So the input is going to be a z dot string. So for validation, you can use Zod, right? So here we are saying that it's going to be a string as the input, and it's a get short URL. It's a get short URL. Get means you are fetching the data. When you are fetching the data, what type of procedure you need to make? You need to make a query. Remember, whenever you are fetching the data, you need to make a query. Can I say that? Okay. Can we go with JavaScript? No, it's a TypeScript framework. So you need to use TypeScript. Okay. So that means we say dot input dot query. Dot query. Are you guys able to get this point? And inside dot query, you can write an async function. Here you can write an async function where you will be having the implementation of what do you need to do whenever a query happens. How many of you guys are able to get this point? Say a yes or no in the chat. First of all, tell me this. That how I am defining a procedure. How I am defining a procedure. This part. So router is a collection of procedure. So you can see we say tRPC.router. What is tRPC? tRPC is the context object that we prepared here. tRPC is the context object that we prepared here. Okay. And we say tRPC.router. This router function takes an object. Inside this object, we will be having key value pair. Every key value pair is going to be a procedure. Let me define one more procedure for you. So we can say create short URL. Create short URL. Now this is going to be one more RPC call for you. How do you make it? You say tRPC.procedure. tRPC.procedure. And again, in a similar way, you are going to define the input. What should be the input for creating, let's say, a URL? What should be the input for creating a URL? Anybody? We can have a object. We can say z.object, right? z.object, right? And inside this object, you can define the structure of the incoming object. So the structure of the incoming object, let's say, is going to be URL, which is going to be of type string. URL, which is going to be of type string. Make sense, everyone? And this should not be any kind of a string. This should not be any kind of a string. We need to do a URL string always. So Zod gives you a functionality to check whether the incoming data is a string or not, and whether the incoming string is a URL or not. If it is, then only this validation will work. Are you guys able to get this point? Yes, Pushkar, you're thinking in the right direction. Hi, Gaurav. Hello. Is this point making sense? Drop a quick yes or no in the chat, guys. Is this point making sense? And then again, you can have a, now this time you are creating a URL, so you need to have a mutation. I believe that is obvious. Async, and then you can have a callback here. Okay. This is a simple way to create a procedure. That's it. That's technically what you are going to go do on the server side. You are going to have multiple procedures created in a similar form. Okay. So let me repeat. As I mentioned, what is a procedure? What is a procedure? You can say procedure can be of three types. Procedure can be either a query. Procedure can be a query. Procedure can be a mutation. Procedure can be a subscription. Very similar terminology to that of GraphQL or maybe React query or something like that. Subscription. Okay, this can be the three type of procedures. And what is a procedure? Procedure is nothing but an endpoint. Procedure is nothing but an endpoint. Are you guys able to get this point? Procedure is nothing but an endpoint. Is this point making sense, everybody? Okay, there are three type of procedure. And collection of procedure is a router. What is a router? If you see what is a router, router is nothing but a collection of multiple procedures. Router is a collection of procedures. Okay, and so on. So multiple procedures together is going to make a router. So see what we are going to do. First of all, you need to make a tRPC object, tRPC context object. What is a tRPC context object? A tRPC context object is an object which is available for every procedure. And using this context object only, you will be able to define a procedure. Okay. So you create init trpc.create, you get the trpc object here. Now, what you need to do is you need to define a router. Router is a collection of procedures. How do you define a router? You take the trpc object from context and you say trpc.router. This trpc.router function is going to define a router for you. It takes an argument which is an object. Inside this object, every key value pair is a procedure. Every key value pair is a procedure. Okay. So first procedure is get short URL. Second procedure is create short URL. Now with the name get short URL, what do you get a sense? That you are fetching the URL. Here you are going to create a URL. When you are fetching the URL, that means the procedure should be of type query. When you are creating a URL, the procedure should be of type mutation. Can I say that, everybody? Make sense? And to define a procedure, you again use the same context object. You say trpc.procedure. trpc.procedure is going to give you a procedure object, right? On this object, you have an input parameter where you can define what will be the input to this function call. So here, the input to the function call is going to be z.string. That means it is going to validate. Zod is going to validate that it's an incoming string. Here it is an object. So Zod is going to validate that it's an object which has a URL property, which is again always a URL string. And the next property is dot query, inside which you can put a asynchronous callback. Here it is a mutation, here inside which also you can put a callback. And that's it. That's how you define the basic structure of a procedure. How many of you guys are able to get this point? Say yes or no in the chat. Make sense? Okay, cool. Now let's try to write a couple of things with the implementation. But before that, if anyone have got any questions, if anybody is having any questions. Which part, Vivek? Which part do you want me to repeat? If you want me to repeat any part, feel free to ask for it. इसमें क्या समझना है विवेक? Okay, देखो, most of the time when you think about in terms of most of the time when you think about in terms of REST API, so REST API may you think with respect to get and post request and put and patch and delete request. Can I say that, everybody? Okay, here you do not need to care about how your how your HTTP call is going to be made. You do not need to care about that. How your HTTP call is going to be made, you do not need to care about that. Okay, what you care about is defining RPCs. RPCs are going to be functions which will internally automatically make the network call for. To make an RPC or to make an RPC function in tRPC, you make a procedure. And the procedure can be of three main types: query, mutation, and subscription. Forget about subscription for the time being. Focus on query and mutation. In query, you write those kind of RPCs which is going to fetch some kind of data. In mutation, you are going to write those kind of RPCs which make side effects. That means which can create, update, or delete some kind of data. Are you able to get this point? So if get is short URL, that means we are fetching the URL, right? What does that mean? It means we need to make a query here because it's going to fetch some data. Of course, if you want to do something else, you can do something else. It's kind of like that. But generally, if you want to fetch some data, you define a query. If you want to create some data, delete some data, update some data, you create a mutation. Is this point making sense? Okay, routes कैसे बनाएंगे? Guys, again, this is not REST API. This is not REST API. If this is not REST API, that means you do not have that slash API slash v1 slash URL. It's not like that. You do not have that. We don't do that here. Okay. We do not have any routes. We do not need to care about any routes. We do not need to care about any HTTP method. We do not need to care about any response code. Anything we do not need to care about. When two systems are going to interact, they are going to interact with function calls, right? These functions call will internally automatically convert your function call to network call. You do not have to care about it. Are you able to get this point? Are you able to get this point? Everybody, is this point making sense? Yeah, yes or no in the chat. So whenever you are going to make a dot query request, it will automatically make a network call with HTTP method get. It will automatically create the whole URL for you. It will automatically send the incoming input data, so on and so forth. Whenever you have mutation procedures, it will automatically create a HTTP method post behind the scenes. You do not have to care about that. Are you guys able to get these points? Yes, you do not need to build API, like you do not need to make routes, you do not need to make separate controller. It's a different way of implementing things. It's a different way of implementing things. Here we just implement things with respect to functions. That okay, this is a function. Whenever we will call it also, we will call it just like a function. Are you able to get this point? Any questions so far? यहाँ तक सही लग रहा है? Everyone, is this point making sense as of now? ठीक है, चलो. So एक काम करते हैं. Let's do one thing. Let's remove this Prisma client from here. Let's remove this Prisma client from here. What we can do is we can say import Prisma client. Import Prisma client. Okay, from Prisma client. And what is a Prisma client? Prisma client is going to be the object using which you can query. Prisma client is going to be the object using which you can query. Okay, so you can say const Prisma is equals to new Prisma client. Okay, cool. Now, how can we query our database? How can we query our database? So inside this asynchronous function, we are going to get access to an object. This object has mainly two parameters: input and context. We are not using anything, like we are not storing anything inside the context. So I'm going to skip it. And we are going to focus on the input. We are going to focus on the input. Make sense, everyone? Okay. And what will be the input? The input is going to be the URL that we want to shorten. Right? Oh, sorry. This is get short URL, right? So input is going to be the short URL for which we want to find the original URL. Can I say that? Input is going to be the short URL for which we want to find the original URL. So you can say const URL is equals to await prisma dot URL dot find unique. Okay, and this is how you make query inside this Prisma URL. You can pass an object here. You can pass an object here where short URL is equals to the input. Are you guys able to get this point? And here you are making the DB call altogether. Here you are making the DB call altogether. Okay. Now, if the URL is not found, you do not return a response. If you remember, like in normal express and everything, you return a response like response dot JSON, and then you say something went wrong, so on and so forth. You do not return a response. It's like a normal function call. You throw an error that URL not found. Okay, you will throw an error. If you found the URL, let's say you are going to return URL dot original URL. Okay, you are going to return the original URL, and that's it. This is a simple query implementation that we can technically have, right? And in a similar way, if you want to implement this mutation, again this async function is going to have an object which we can restructure, which will be having an input parameter. And the first thing that we can do is we can say const short URL. For now, I'm creating a short URL using, let's say, math.random function. So I'll say math.random, okay, dot toString. So we are going to create a 36 character string. Okay. Right. And from that, we are going to take a substring. We can take a substring, let's say initial 7 characters, or let's say from 2 to 8, something like this. Okay. We can calculate a substring. So for now, you can say that if you use this JavaScript function, let's say, let me show you on browser. Okay. It's a simple JS function, nothing much. If you carefully see, it's kind of like creating a random string for us. So what mat.random.toString this will do is it's going to create, first of all, a bigger string for us. And then from that, we can calculate a substring from 2 to 8. Okay. So just a simple thing we are doing. Right. For like now you can talk about like, okay, what's the best way to create a shortened URL from original URL? There are two main mechanisms. Either you can create random strings and check whether that random string already exists or not as a shortened URL allocated to an existing URL. If that already exists, then you don't want to use it and you recreate a random string again and again. Or what you can do is you can use some hashing algorithm to actually create this random string, right? So that's a different discussion altogether. I want to focus first of all on tRPC. So for now, we are going to create a random string and use that as a shortened URL. Okay. And we are going to say await prisma.url.create. We are going to pass a data object. In the original URL, we are going to say input.url. And in the short URL, if you carefully see the Prisma file, short URL. So in the short URL, we are going to pass the short URL that we technically created. And that's it. And from this function, we are going to return the short URL. Right? We don't need to return any JSON. We don't need to return anything specific because it's a function call. Functions just return simple values. So this function was expected to create a shortened URL. So we are returning the shortened URL. Is this point making sense? Yeah. So I don't want to go into that hashing logic, that exactly how we can have a separate discussion on how you can make an interesting, or I would say a foolproof URL shortener altogether. Currently, we already have tRPC and the complexity of tRPC to discuss. So I'm simplifying that for now. Are these two function calls making sense to everybody? Say a yes or no in the chat. Are these two function calls making sense to everyone? tRPC versus gRPC. gRPC is an overall ecosystem available for other languages like Java, C++ as well. tRPC is only for TypeScript. First problem. Second problem, tRPC enforces you to have kind of like a monorepo. gRPC doesn't. Okay. Any questions? Any questions, guys? Anyone having any questions? If no questions, should we like move ahead? Okay, chalo. Okay, cool. In that case, we have all of this setup. We have all of this setup ready. This looks good to me. Now we can set up a simple Express file. We can set up a simple Express server. So I can create a new file, index.ts. Okay, and I believe I didn't install TypeScript and everything, did I? I didn't install TypeScript and everything, right? So let's also install TypeScript and TS node so that we can just very quickly run this TypeScript server. So I'll say npm install TypeScript and let's wait for it. and I'll install npm install ts node. Okay, npm install ts node, and I'll also do npm install @type/node, and here we go. Most of the things should work fine. Also, we need to install the MySQL2 driver, otherwise npm install MySQL, otherwise the MySQL queries can create problems for us from Prisma. So MySQL2 driver also we have created. It's a simple ORM setup, so I don't want to bother a lot. And now we have everything set up already. Now what we can do is we can set up a Express server. We can set up an Express server. Okay. I would like to come up here and let's see. We can say import Express from Express from Express. Okay, so we have got Express, right? We can also install course. Let's install course, npm install course, so that we don't have a cross origin issue. Okay, we can say import course from course. Okay, so we have got course as well. We'll import our URL shortener router. You can see we got the router. Is this point making sense? And what we have is tRPC gives you an adapter that you can connect with your Express server. This adapter is kind of like an interface in which Express will receive the request and correspondingly convert everything for tRPC altogether. Okay, how can you do that? You can say import star from @tRPC/server slash I guess it's inside adapters. Okay, let's quickly check. Maybe we have to separately install it. tRPC server Express adapter. Okay, you can see Express adapter, and let's scroll down. Okay, this is the import. I'll just directly take it from here without much of a discussion. And you can see we got tRPC Express. So you can say it's kind of like an interfacing that is going to allow Express to receive request and then just directly convert that request accordingly for tRPC. Does that point make sense? Now we need to create a Express app object. We need to create an Express app object. We need to enable course. And we are going to add a middleware inside Express. Right. This middleware is going to say that if any request comes to /tRPC. So what tRPC, just like we have a tRPC server, we have a tRPC client package as well. What tRPC client package will do is any request now, because how the client is going to communicate to the server, client is going to communicate to the server using a function call. So whenever client is going to make a function call, it is going to convert that function call into a network request. Every network request will be starting from /tRPC, because eventually if you have a network request, you will be having a URL, right? You do not have to care about it, but tRPC internally converts it. So tRPC is going to convert it with /tRPC. So what we are going to say is that if any request comes with /tRPC, we are going to route it with tRPC express dot create express middleware. So you have a create express middleware function inside which you can define your router, URL router. You can find your router. Okay. And what this line is going to do, is this line going to make sure that if any request comes with /tRPC, it is routed towards this. Make sense? And we can just start a basic server running on port 3000, and that's it. This is how you are going to set up an interfacing between Express and tRPC. Does that point make sense? Anybody having any questions? Anybody having any questions? So you do not need to set up your routing file, API versions, anything you do not need to do. You just set up functions and that's it. Of course, you can like segregate it out in separate files and everything. That is something that you can do. Okay. And this is kind of like an interfacing. Again, I'm explaining the interfacing that Express is going to be the server, because like your browser doesn't understand RPCs, right? Browser understands what? Browser understands your normal HTTP calls. So browser is going to make an HTTP call, but because those HTTP calls are going to be powered by tRPC, and we are going to write a tRPC client function. Those tRPC client functions are going to automatically convert those calls into network request. All those network request URL is going to start with /trpc. So I am saying here in my Express server that any request, if it comes from /trpc, routed to tRPC Express adapter, this Express adapter just do one thing. It takes the router and maps it to your corresponding router, which is the collection of procedures that you have. Make sense? It's going to validate the incoming request. So Salman is asking what will happen if a normal REST API call hits the /trpc route. If it does, then it's going to do the validation. If the validation goes through, then it's okay. If it doesn't, then it's going to throw an error. Yeah, Nikhil, you can even use that in that way. Okay, so we have a basic Express server setup up and running. I would like to close all of this for now. So you can see this was our backend. Okay, now I'll go back to my monorepo and I'll go to my front end. I believe it was a client. Okay, I'll go inside the client. Now what I'm going to do is I'm going to create a new Vite project. npm create vite@latest. What is Vite? Vite is going to be the tool using which you can set up a React project. Don't worry if you don't know about React. It's like pretty simple. We are just setting up a client. So focus. Let's focus on that. Okay, and let's say we are going to call it as front end. Okay, we can choose React. We can choose React. We can use, let's say, choose TypeScript, and here we go. We'll say front end npm install. Okay, and here we have to install a couple of things. Now, just like we installed tRPC server for the backend code, here we have something called as tRPC client. Here we have something called as tRPC client. So let's use that. Okay, let's wait for it. Okay, now what we are going to do is we are going to install tRPC/client. Now this is going to give us all the required interfacing to prepare the tRPC client. Okay, and apart from this, there is one more interesting package called as tRPC React Query npm. Okay, what is tRPC React Query? So the tRPC React Query library is going to give you a very nice interface using which you can use React Query with tRPC. Okay, so if you come, you can see a huge number of weekly downloads are there. If I actually show you, one second, if you go to tRPC, and I believe they must have mentioned it somewhere, you can see React Query integration. So tRPC offers a first class integration with React. Under the hood, this is simply a wrapper over the normal tan stack query. Remember tan stack query? Like you must have heard about tan stack query or React query. So if you have, and I was again and again saying also that in React query also you have queries and mutations. So that's a similar thing that you are going to do here. So for that, you all you need to do is you install @tRPC/React query. So this is going to give a good interfacing for you to integrate React query. And you need to separately install React query as well. How do you install React query? You say @tanstack/React-query. Okay, again, it's a front end stuff. If you do not understand it, don't worry. It's going to just go away in a minute. And we are going to also install Exio so that we can make the API calls. So let's install all of this. Oh, my bad. There is a spelling mistake. Cool. I'll also quickly set up Tailwind. So I'll say npm install -d Tailwind. Okay, we'll set up post CSS and auto prefixer. Just to write simple CSS very quickly. Let's wait for it. Any questions if you have, feel free to ask. I'm adding these as dev dependencies. Also keep that thing in mind. And what I'm going to do is I'm going to initiate a Tailwind CSS config file. Okay. So, once again, I believe it should directly do Tailwind CSS init -p. One second. I guess I'm missing some step for Tailwind. Let's quickly go to Tailwind Wheat. Okay. Let's go here and okay, I was doing right. Why didn't install Tailwind then in that case? Okay, it's asking me to install maybe an update. Let's do that. Okay, so you can see the files are up. I'll open this project in VS Code, and this is our front end. This is technically our front end coming up. Make sense? Now what we can do is we can go to Tailwind config file and very quickly just copy paste the configuration from here. So I'll paste this content. This is just enabling Tailwind in multiple JSX, TSX, every different kind of file. Save it. So our this Tailwind configuration is ready. One last thing that we would like to do is we would like to set up the Tailwind. You can see directives. We can go to source/index.js, index.css, remove the existing CSS and paste it here. And technically, Tailwind should be up and running for us. Make sense, everyone? Ah, got it. I guess I installed Tailwind here instead of Tailwind CSS. Yeah, that's why it was okay. That was the problem. Cool. I guess now it should be good. Now it should be good. Cool. I'll remove all the other irrelevant CSS. We do not need all of that. Okay. Now let's start setting up things with our client. So the first thing that we are going to do is we are going to create a new file. We'll call it as, let's say, trpc.ts. Okay. And here we are going to set up trpc. Now, if you want to set up trpc, on your front end, what you need to do is you need to kind of like create a proxy object. Now, I'm not sure how many of you guys have heard about proxy, right? Proxy is something that tries to mimic something else. What is a proxy? Proxy is something that tries to mimic like something else, right? For example, let's say in your college, your friends must ask you to do a proxy for you. So you act like as if your friend is present in your class. Are you guys able to get this point? Right? So here also, we are going to create a proxy object for us. Let me show you how you can do that. So we are going to import create tRPC proxy. Okay, so there is create tRPC proxy client and HTTP batch link. So there are two, I would say, important. You can see there are two important functions. These two. Okay, what these two are going to do, let me tell you. So this tRPC proxy client is going to create a tRPC proxy for you. tRPC proxy for you means that your browser is going to make a normal HTTP call, but those HTTP calls are going to be converted into a tRPC call. Okay. And what is this HTTP batch link? This is kind of like an optimization that tRPC does, right? To make sure that any kind of a redundant HTTP request is not made. So it's going to batch if, let's say, there are multiple requests going on, and if they have a capability, it can batch your requests altogether. So what you can now do is you can say const tRPC is equals to, you can create a proxy object. You can create a proxy client. And what should be the type of this proxy client? The type of this proxy client is technically going to come from your backend. Remember, from your backend, you actually were setting up a URL router. Remember? How many of you guys remember that? Okay. So if I show you this tRPC proxy client, tRPC proxy client. Okay. Set up tRPC client. If you carefully see, then what you have to do is you have to import your app router type in the client application, and you create a tRPC client. And do you see where you are importing it from? You are importing it from your server. How many of you guys are able to get this point? You are importing it from your server, because your server has all the details about the router. And if server has all the details about the router, router has all the details about the procedure. Can I say that? Yes or no? How many of you guys are able to get this point? Your router has all the details about the procedure. Can I say that? And your your router is technically present in your backend. So you need to import that from your backend. Can you see? You have to technically import that from your backend. First of all, tell me this. How many of you guys are able to get this point? How many of you guys are able to get this point? Okay. So how we can do that? We can go to our backend. We can go to our backend. We can go to the router. And from here, we can export one more thing. We can say export type URL router by doing type of URL router. Okay, so this URL router object that we are having, we can export its type by doing export type URL router. Are you guys able to get this point, everyone? Is this making sense? Is this making sense, everyone? And we can import it inside our client. We can import it inside our client. So let's first of all import it. So I'll say import URL router. Let's take the same name, URL router. That's a export that we are doing from here, URL router. From, let's go. We go one step back, we go another step back, we go another step back, we go inside the backend, we go inside source, we go inside routers, and we go inside the URL router. Make sense? And we have the URL router type. So here also this is going to be of type URL router. Make sense? And inside this you are going to define the links. There is a links property that takes an array, and you can define a HTTP batch link. You can define a HTTP batch link. Okay, this is just a client setup. This is a one-time setup that you have to technically do. Okay, it takes an object which takes a URL, and here you have to mention whenever you want to make a procedure call, remote procedure call, which URL you want to hit. So we want to hit HTTP / localhost 3000 / tRPC. This is going to be the URL which will be hit whenever you are going to use this tRPC client object to make a tRPC call. And I'll say export default tRPC. How many of you guys are able to get this point? This is a simple setup which is going to give us a tRPC client object. Let's call it as tRPC client. Let's call it as tRPC client. Now, whenever using this tRPC client, if you make a query request or a mutation request, that will be automatically going to this URL. Got it? Without connection, yeah, that's the part of monorepo, right? That's why I said you need to have both the front end and the back end in the same repo so that you can import it here, right? And that's it. To be very honest, that's it. This is the only major setup that you have to do. Now you can start setting up your components. Okay, so let's go to app.tsx. And I'm not making a lot of other components here and there. Okay, so for now, I'll just remove everything from here. Okay, and let's try to set up something very basic. I say hello world to my URL shortener. Okay, hello world to my URL shortener. Okay, and I'm going to set up a few things. I'll say const URL comma set URL. Very basic React I'm going to write in front of you. Use state and an empty string. Okay, and we are going to set a short URL as well, right? Two state variables we are going to keep. Make sense, everyone? And we are going to say, let's have a function handle submit. Let's have a function handle submit, which is going to be an async function. It's going to take an event object, which is a React form event, which is going to be a React form event altogether. So you can say react.form event. Okay, and here we go. Now we can start the implementation. The first thing that we are going to do is e.prevent default. We want to prevent the default form submission. If URL doesn't exist, then we are going to return undefined. Otherwise, we are going to try and catch. If any exception comes up, we are going to just say console.log e, and let's say we say console.log something went wrong. Very simple. Okay. Something went wrong. Otherwise, now this is going to be the interesting part. Now from here, you have to make the endpoint call. But the endpoint call is not a normal API call. Can I say that? It's not a normal API call. It's a tRPC call. Can I say that? It's a tRPC call. So what you can do is you can say const response is equals to await. Now you need to get your tRPC client. So I say tRPC client dot. Can you see it has access to both the functions? If you carefully see dot, it has access to both the functions. Can you see, everybody? It has already access to both of the functions. How it is having access to both of the functions? Because we mentioned the type of the router here. That means the collection of procedures we have already mentioned here. And now I can just say dot create short URL. I can just make a create short URL API call. And I need to mention that, okay, it's a mutation, right? So I'll say mutation. And let me even show you just a quick example here. So you can see you set up this tRPC client object and you can see dot query dot mutate, and that's it. Okay. So I'll say dot mutate. Okay. And we have to pass an object. Do you remember what was the object like? The object needs to have a URL property, which should be a actual URL. So we are going to send the URL here, and that's it. This is the response. The response we are going to set as the set short URL as response. That's it. Make sense? Because in the response, you are directly returning the short URL. In the response, you are directly returning the short URL. And can you see? I do not have to care about HTTP request method, HTTP request URL, all of those things I do not need to care about. I can just make a function call. I can now just make a function call altogether. Can I say that? Okay. Make sense, everyone? Everybody, is this point making sense? Say yes or no in the chat. Okay. Now let's try to set up the UI. A very basic UI I'm going to start setting up. Okay. So let's say let's remove everything for now. Okay. I'll put a div in place. I'll give it a couple of class name. I'll say minimum height is going to be the screen height. Okay. So minimum height hyphen screen. So I'll give it a minimum height as the screen height. I'll say display flex, items center, justify content center. Okay. Background gray 100. Okay. That's a simple plain div. Inside this div, I'm going to have another div with a couple of more classes. So I'll give it a padding of the 6 unit from every side. Max width is going to be small. Okay. And we are going to say BG white, rounded large maybe. Okay. And we can give a shadow MD. Okay. Cool. I can give a H1. Oh, sorry. This is a H1. Inside the H1, I can say URL shorty. I can give a couple of classes here and there for URL shorty. I'll say text to Excel, font bold, and margin bottom 4. Okay, pretty simple. And now we can set up a form. Okay. The on submit of the form, of course, will be having our handle submit function. Can I say that? The on submit of the form will be having a handle submit. We are going to have an input tag. My bad. We are going to have an input tag. Okay. Inside this input tag, the type is going to be text. Placeholder can be enter your URL here. We can give a couple of classes: width full, padding 2 units, border gray. I'm going with whatever Copilot is suggesting me. Okay. The value property should be URL, and the on change we are going to get set URL. As simple as that. And below this, I'll be having a button. Which will say shorten URL. And this button, we will make it of type submit, and a set of classes automatically from Copilot I can give. Make sense? And below this form, I will say if short URL exists, then we are going to say, let's say a p tag. Inside the p tag, we'll say your shortened URL is, and let's say I'll just print the short URL for now. Okay. And let's style this p tag maybe. Okay, we'll style this p tag as well. That's great. And more or less, this looks like a good UI to me. Okay. Any questions from anyone? Any questions from anyone? Okay. If no questions, then let's try to run our application. What do you guys say? We have the client setup, we have the server setup. Both of the things are looking more or less fine to us, right? Let's try to run the code. Okay. So the first thing that we can technically do is, let's keep front end in a separate terminal. cd developer tRPC demo, cd client front end, and I can say npm run dev. Okay, let's see, there are a couple of issues. Post CSS plugin cannot find the module tailwind CSS. One second, I guess that installation error is now causing issue. Package.json. We have installed tailwind. We do not need to do that. Okay. And I'll delete the node modules very quickly once. And I'll do npm install once again. Okay, let's try to run it now. npm run dev. Okay, still has an issue. Let's see. Client front end ls. Okay, we have everything. It says loading post CSS plugin fail. Cannot find the module tailwind CSS. Interesting. So let's install the whole tailwind CSS part once more, maybe. Why it's causing an issue. Tailwind wheat, and let's see, copy. Here we go. Okay, let's try to run now. npm run dev. Okay, yeah, you can see the React server is up. Can I say that? Okay, cool. Now for the backend, we'll go to the backend, cd backend, and I'll say, let's say npx ts node, and let's see where is our index.ts file. It's inside source, right? So source/index.ts. Let us see. Okay, we have a couple of issues. Let's just quickly check. Okay, we have not installed types for express, so let's do that. npm install type/express and type/course. Let's run it again. Okay, and you can see server is running on port 3000. Let's see what do we have on the UI. Let's see how does the UI looks like overall. Localhost 5173, and you can see we have a URL shorty. If I inspect, go to network tab. Okay, let's paste a URL here. So I'll paste this URL. Let's see this tailwind CSS URL. Okay, and let's try to keep an eye on what happens in the network tab. If I click on shorten URL, you can see your shortened URL is this. Okay, so it's just returning us the URL code, no problem. But can you see it made an API request here? Can you see it made an API request here? Click on this. First of all, it's an HTTP request. Yes or no? Did you from your client anywhere mentioned that you want to make an HTTP request? No, you just made an RPC call. And it's starting from /tRPC. And that's what I said, that if any request comes from, let's say, where's the backend? Here's the backend. So if any request comes from /tRPC, we are going to reroute it to our URL router. And it was a mutation. If it was a mutation, automatically the request method is post. Can I say that? Can I say that, guys? And can you see content type application/JSON? If you see the payload, can you see the payload is still being sent in the form of a JSON? Can you see? It's still a JSON. Response is still coming in the form of a JSON. But in your code, do you need to handle JSONs? No. You are just handling your normal TypeScript types. You're just handling your TypeScript types. Here as well, in the client, you are just handling your TypeScript types. It is automatically going to convert your function calls to normal HTTP requests. Is this point making sense, everybody? Say a yes or no in the chat. Right. Now you do not have to care about like what is the API method and so on and so forth. You do not have to care about that, because your tRPC client will be having access to all the corresponding router procedures. You can just call it like a normal function call, and it nowhere gives you the feeling that you are making a JSON REST API call. Just like you called create short URL, what I can do is, let's say, let's do one thing. Okay. On the use effect, let's say on the use effect, that means on the first load of this component. Okay. Let's import it. Let's call one function, const get all URLs. Okay. Let get all URLs. Okay. And we can say tRPC client dot get short URL. Okay. Dot get short URL. And you can see this was the get short URL function, right? You pass the short URL and it is going to give you the original URL. So let's take the short URL from here. This was the short URL, right? This is the short URL. Copy this. And just like I'm going to hard code it, get short URL dot query. Okay. And how do you make a query? How do you make a query? You can give it a input, right? Can you see? This query is expecting an input which is of type string. So let's say I just give it a type string and that's it. Okay. And I'm going to call this function on the first load of the component. On the first load of this component, I'm going to call this function. Let's see whether our query is working fine or not. If I save it, if I come back, and if I just refresh once, okay, can you see there is a call to get short URL? Can you see there is a call to get short URL? And can you see the response? We are getting the response back. Can I say that? Why there are two responses? Why there are two responses? Because of course, in main.tsx, you have a strict mode enabled. For now, if you just remove the strict mode, save it, and just run it again, Now can you see you just have one response back? And did you just realize it was batching your request? If you were making two simultaneous call, it was just batching your requests all together. And in the console, you are getting this printed as well. So that's how you make a query. That's how you just make a query. Are you guys going to get this point? Okay. So I'll upload this on GitHub so that you guys can play. Like, of course, now from here, you can make a lot of features to this URL shortener. Whenever we create a shortened URL, you can check whether that URL already exists in the DB or not, so on and so forth. Just if you want to see the situation of our database, and if I say select star from URL, you can see we have one entry. This is the shortened URL. So now I have a task for you guys. Whenever somebody comes for our, now how URL shorteners work is, if somebody comes to localhost 5173 slash this URL, you need to redirect them to this original URL. This is the take home task that you guys can take. Okay, this is the take home task that you guys can do. That if anybody, because how Bitly and everything works, Bitly creates a shortened URL for you, then you can go to bit.ly slash whatever is the shortened URL, and it redirects you to the original URL. Now I want you guys to do that. I want you guys to implement the redirection part inside this repo. Okay, so I'll just quickly upload this repo. I'll say URL shorty using tRPC. Okay, create the repository. And I'll just do one thing inside my backend as well. I'll make a, oh, I already have a git ignore. So this looks good. This looks good. And now what I can do is I can come to back to my repo. I'll say git init, git add all. Let's add the remote. Git push. Here we go. Oh, sorry. Git checkout. Push. And if you just refresh, then you can see both the backend and the client code has been uploaded. And now you guys can come up and try to implement this redirection part. Any questions on this implementation so far, whatever we have done? Any questions? Okay. Okay, Vivek is asking what is the benefit. Vivek, do you remember what was the problem? I talked about the problem initially. Right? Do you remember the problem with REST APIs? Not JSON. No type safety in JSONs. Not just JSON. There was no type safety. So everything around type safety you have to implement yourself. Guys, let me show you one thing. So so I have a repo here. Okay. So this is a REST API based TypeScript microservice. Okay. It's set up in Express. You can check that here, probably index.ts. You can see it's set up using Express. If you remember, or if you carefully see, all the validations and everything we have to take care ourselves. We implemented this kind of a schema, right? Then in every API call, what do you need to have? You need to have your dedicated DTOs. You need to write your own DTOs, and then you need to validate these DTOs, so on and so forth. That's a manual effort. You do not need to write any DTOs here. Why? Why do you not need to write any DTOs? Because it's function call. You just say what is the input of the function. That means what are the arguments to the function, and you write the implementation of the function. That's it. You do not need to write any DTOs. You do not need to implement your own level of manual type safety. That's the benefit. Make sense? Any questions? Anybody else having any questions? So you can go to this URL. You can go to this URL and try to implement that redirection part. I would love to see what efforts you guys are making there. Make sense? I can maybe quickly add a README to let's say just set up the project. Okay, let me just quickly add a README maybe. So vim readme.md. Okay, steps to run the server. I would say tRPC server and client. Okay, first go to the backend folder. How do you go to the backend folder? You can say cd backend, run the express server using ts node, and before that install the dependencies. Install dependencies. How do you install dependencies? You can say npm install. Okay, and you also need to do Prisma client in it. So initialize Prisma client. Okay, so if you remember the Prisma client command, npx Prisma client migrate, you just execute this command and it should initiate everything for you. Okay. Okay. And then you can run the server probably. You can check if any other step you need to do for Prisma. Okay. You can say ts node npx ts node source/index.ps. Okay, this is how you run your backend. Then fifth, go to the client. How? You can cd client/frontend, install dependencies. How? npm install. Seventh, run the React server. Okay, nothing else. npm run dev. There we go. That's it. This is probably most of the things that you technically need to do. There we go. If I just quickly refresh, so you can see I have written a couple of steps. Just try to do this. Just check in case Prisma migrate only doesn't work. Maybe you have to do a Prisma init also. Just check that. Right. I guess we are already doing init, so you don't need to do. But just check if any other Prisma step you need to do, and that's it. These are all the steps using which you can run the tRPC server and client. Okay. You can try to create a PR, guys. You can try to create the PR. Okay. You can deploy the setup on AWS. You can, for React deployment, you can use AWS Amplify. For the server deployment, you can use some simple EC2 machines. GraphQL is already uploaded. You can check. I created a video streaming app for GraphQL that's already uploaded on platform. You can check that. Thanks, Surya. Thanks for that. Okay, chalo. That being said, let's wrap this particular session here. We are going to meet soon in the next set of sessions where we will talk about some more interesting stuff around something around backend, front end, something. Till then, take care. Bye bye. Have a great week ahead and keep coding, guys.